Yes, ma'am. Good evening, ma'am.
Good evening, madam. Good evening, all participants. Good evening, Mr. Sundar.
Good evening, sir.
Good evening, sir.
Good evening, Mr. Sundar.
Good evening, sir.
Mr. Sundar, your boss is available in sitting.
Yes, sir. He is
Mr.
available, sir.
Elil. Mr. Elil is available.
But unfortunately, sir, he is in meeting now.
Okay.
We have our AG80 head, sir, in the line.
No, not an issue. He's available now
Okay.
because I want to meet him.
We will let him intimate the issue, sir. We'll make the progress, sir. We will make it. We will be supporting you, sir. We'll convey this to our L, sir, and he'll be joining too soon, sir.
Hello.
Shall we start, sir? HOD, sir?
Madam, we'll wait for another 2-3 minutes
Yes, sir.
because now the participants are 40. There may be a possibility of joining. We
Yes,
wait
sir.
for
Yes.
another 2-3 minutes.
Yeah, sir.
Okay, madam, you can start. Bharati, madam.
Good evening, everyone. I welcome everyone for this webinar on factory automation. I hope the next 1 hour would be informative and interesting session. Now I request our HOD, Dr. P. Jnanashivam sir, to introduce the speaker.
Good evening, all participants, and I welcome our guest Sundar M, Senior Application Engineer. He is actually a BE graduate from Anna University. Actually, given more than 100 seminars, guest lectures, and he helped the students in industrial visit. So many experience he's having in related to explaining the students about these programs. and he is practically involved in more than 15 industrial projects across South India, and he is actually a senior application engineer, and his job includes commissioning, providing services in PLC, robotic vision, robotics, vision system, SCADA, HMI, communication protocols, etc. He used to support research and development works on industrial automation sectors and also providing hands-on training to industrial personnel. Actually, his industrial experience is excellent, and he hold many projects at present also. I welcome Mr. Sundar. Please, you can proceed with your presentations.
Thank you, sir.
Thank you very much.
Thank you. Um, Thank you, sir. Thank you for your intro. Basically, I'm too from EC department. I too have done microprocessor based and lab view based project while I'm doing in my college. But what in this field, what I'm personally feel in this field is that it's a multi versatile department. So we need a mechanical person, electrical person, communication, programming engineer. To be, it's a multi diverse department. So initially, I like to mention that whenever I used to visit some top notch, even the top notch college like IIT Madras or Tyagaraja College, Madurai, some other colleges, uh, there is a slight hesitation among the students. Am I able to get into this field, robotics field, even though I don't have any uh, uh, UG or any background in that field? But it is not like that concern. And I also expect the students to be very interactive. And this is not your college session, so it's a very you can be very open with the technical knowledge sharing. So I can learn from you people. So you'll be covering, since you are in college, you'll be keep on update on the new concepts or new technologies which is being introduced in the market. So since we have been dedicated to industrial platform, we restrict our complete knowledge platform over the industrial environment. So we'll be focusing on how to program a robot, how I can improve the productivity of the industry. So we even can learn from you, and that's why I'll say that this is to be an interactive session. So I'll be sharing my insights and our experience in the field. So I expect everyone to be interactive, and if there is any doubt, if you want to clarify, if you want to have a discussion session, we can make it over the last 15 minutes or last 20 minutes. So that will be helpful for us. And and I expect that everyone need to be mute, at least mute in terms of students. Actually, if you are unfortunately, if you are accessing the audio or some other disturbance, it might be a disturbance to some other people too. So if you are unable to see video or any slide, you just try to log out and just relog in it. And if you are facing any issue, just raise the questions in question and session inquiry panel area. So we'll be discussing at that time, last time. Okay, and let us go into the presentation. And today, what is the topic we have is that Yaskawa Motorman's implementation in factory automation. How these our Yaskawa robots been utilized, and how it is helpful for the factory-based industries. Being application engineer since 2015, I have been in this field for almost 5 years, and we have seen numerous kinds of environment. I have personally worked in Coimbatore, Pondicherry, Chennai, Hyderabad. These are the areas where I used to work in South India. So we have visited and we have worked for multiple departments. For example, we have worked with the CNC machine manufacturers, and we have worked with the PCB board developers, and we have worked with food-based industry. So we have whatever may be the industry, we have at most we have reached any one of its own kind. For example, even we have worked with the drainage sewage treatment plant to we have done to till the defense sector too. So we have diverse exposure, and we'll be sharing how we have worked on it. And since this topic is being dedicated to robotics, I'll be sharing what are the applications of industrial robot and how we are doing the project. For example, how we used to select the robot and how we used to program it. So we'll be having a discussion related to the Yaskawa based robotic system. And this is my group of company. Actually, I'm working for Access Global Automation, whereas we have a separate training related department, and this company AG80 is to dedicatedly work for the industrial based training. Not only the staffs and students being covered, we even have used to take training for the industrial persons. We have many students from Ford, and then some tractor based companies, Samsung, and then a lot of industry person used to get training over that too. So they'll be updating for their promotions and their next level improvement. Some persons, those who have been experienced, they might have worked in Dubai or some other country. They like to update their knowledge in terms of DCS or some other PLC. Once they updated, they just in the vacation they'll be utilizing that vacation in this manner for the education purpose. So for that too, we used to provide training in AJ80. And being from Access Global Automation, we dedicatedly meant for working for a customer based solution. We have most probably in Chennai, we used to work with automobile sectors. We work in terms of arc welding based robotic painting, welding, pick and place, palletizing, and multi diverse environmental industrial factories. So these are the concepts, these are the areas we have been expertise. We in Coimbatore zone, we have a lot of experience in paper bills mill and water treatment plant in Tirupur. HVA system for mainly for industries, for home based automation. For example, we have worked with the some topmost hospitals and even the hotels management. For that, we have developed car parking mechanism in Vadapalli based multi complex. So we have such exposure too. And apart from that, we have developed special machines for defense and aerospace industries in Chennai and Ambattur and Coimbatore too. Even we have worked with multiple plants. And majorly, being a robotic engineer, we dedicatedly work for the automobile based industries. It's the most concern area of our field. Okay. I hope everyone might heard of the word called mechatronics, which is being coined by the Yaskawa engineers, and they have raised this field, and they used to recruit in terms of this department. So it's a multidisciplinary field, and this Yaskawa has been a brand since 1914. So you can understand it's a 100-year-old company, and they have entered the robotic field in terms of 1970s. They started the product in terms of geared motors and other DC motors and AC motors. Now they are one of the largest automobile giants in the world. It's actually a Japanese brand, a subsidiary of an American company. They have revolutionized a lot of concepts in the industry. For example, you might have heard of ultrasonic welding. I hope you might have visited some industries for IV. So you might have seen some, most of the plastic molds in the industry will be uh, welded in terms of using ultra wave sound. So we are the first to introduce that in the entire world, and we are the fastest welding robot in the current market. So what may be the job, we able to make it in terms of very fraction of second when comparing with the human and other performance, other computers performance. And we are the first to introduce 15 axis robot. I will show what is meant by 15 axis robot. I will be sharing those videos too. Okay. Let me show you a slide video of our company profile so that you can understand what we used to do and how we used to give solution to the customer. Hello, Murugan sir. Sir, actually I'm unable to get the editing purpose. It's been disabled now.
One second, one second. Now we check it, Sundar.
Okay, sir. Okay. I hope you might have got some idea what are the concept we used to work. So Yaskawa is one of the Japanese brand, and I have already mentioned that uh, these are the facts we have developed. And since still now we are the fastest robot development, and we used to do programming. Actually, most of the people used to think that we used to develop robot. Actually, technically not. The robots being manufactured by Robo itself in Japan, and we used to import the robot. And we are the ASP for the Yaskawa Motorman Japanese-based company, and we used to give solution. For example, if a customer want to do a welding for a chassis for a truck, or if the customer want to do painting for a silencer, or whatever may be the customer's requirement, we used to give it solution in terms of robotic application. How we used to work is that we'll be getting the data. For example, we have worked with the Yamaha in terms of Yamaha bike manufacturing unit in Varagadam. So we have worked for the painting mechanism over there, where we have to do paint coat for the all bike models. We have Fazino and some other bike race model, exported model, and then for FZ model too. So we'll be getting the job, and we have to do a painting. So we'll be getting the exact structure 3D data from the customer, and we'll be taking study in our software. So in Ashkawa we have dedicated software to take trial, and multiple programming trial will be taken. Once we got succeeded in the, and we'll be checking the reach, how the robot can approach them, and how the robot is it possible to cover the coverage of entire specs of the customer sample. So only after taking multiple trial we'll be able to do in terms of real-time practical implementation. So this is how we used to work. And what is the fact we have what is the technology we used over there is that the jobs will be mixed in the random mixture. For example, I won't get the Fazino model for 100 times or 200 times. If a job first job is about Fazino model, then next job might be a bike racer model or some other model. So the job used to keep on changing. Being an engineer, what we have used is that we instead of we tried with the sensors, but when we are trying with the sensor mechanism we fail. We are unable to distinguish the difference brand, since almost all jobs in the same color and some physical difference is being observed. So instead of using the sensor, we utilized some camera system. That camera used to identify the difference between these models, and that acts as an eye for a robot which give this model has been arriving, and the corresponding program will be executed. So this is one of the sample how we work and analyze for the customer. So we'll be used to import the robot, you'll be giving solution for the customer. And according to customers requirement, we used to develop a protocol, and we used to develop a coding and other external environment too. This is how we have giving solution for the customer, used to give solution for the customer. And before seeing into technical part, we have today's session will be a a brief interview of overview of how the robot will be function and how it's working. So before that, we need to understand what is meant by industrial robot. We might have slightly confused by see watching in the movie the robot what we have watched in the film is completely different than the industrial environment. That's why I showed that that video in the early session. Of course, you might have seen some these robots in real time advertisement too. In some ad you can see in even some Hollywood films, you might have seen some industrial robot. Even in Iron Man and Independence Day movie, you might have seen this industrial robot. And I like to differentiate how this industrial robot is different from the robot which is based on the embedded platform. If I want to categorize a robot as an industrial robot, I need to have a minimum 3 or 4 axes. So any robot can be considered as an industrial robot. It need to be operated with 3 axes, and it should be a programming of automatically controlled, and it can be reprogrammed and reused. For example, if I'm using a welding model robot, that robot model can again utilize for some other purpose. For example, I can make the welding robot to be modified as pick and place robot too. Ishka, we have such provision. So it should be multi-purpose application, and manipulator is nothing but what you observed in the video. That blue color movement structure, no, that actually called as a manipulator. It's not an entire robot. It's a part of a robot. What you are seeing. The robot term used to be. I will be explaining the further session. What you have observed is a manipulator. So if you want to have an overall structure, robot consists of a separate controller. We need a sensors. Then we need a manipulator. all and teach better. All these four structures basically join together form as an industrial robot. So this is how these robots been different from the embedded based robot. You might have I think you might have developed some AGV structures, you might be developed some line followers. So this is a basic difference. If I want to take it as an industrial robot, it must have three axes, three different axes at least. So most of the industrial robot used to come with six servo based, six axis movement or 6 degrees of freedom based structure. Okay, and I like to ask a question that who can perform better, either a robot or human? You can give me a reply in terms of chat, so it'll be very easy for me to understand and to understand your perspective. Human. Okay. Yes, Mr. Gautam, you can text now. Any answer? Any other answer? Okay. At the end of the session, we can again continue this. Uh, uh, we can discuss about this too. I will explain how what is the real expectation and what is the real answer for this question too. Okay. And basically, there are three basic laws for the industrial robot. You might have even seen the iRobot introduction of the film. Might have seen these three laws. Robots been designed that you should not harm human at any cost, whatever may be the command. Even if I am giving a command to kill a person, robots are not supposed to behave like that. So this differentiate. This industrial robot has been actually a technical slave of a industrial for a human, not as a AI based robot is completely different. It can think by its own programming language. It can behave by itself, but industrial robot is not under that category. That's why I like to differentiate too. So these robots been designed to not to harm any human, and the second law is that you should obey all the commands from the human. For example, if I have written a program to do a welding for circular job, the robot must work for the circular motion. It's not designed to move in the random or zigzag movement. So it should obey the human command and should not be conflict with the first law too. And as a third point is that robot must protect its own existence. For example, if I am approaching robots being supposed to approach a obstacle, it may get damaged. It should ask for a human whether it's is whether to continue or not. So it have some basic functionality to protect itself and without conflicting the both two laws that I have mentioned earlier. So for example, what is the major drawback in the industrial robot is that robot need a separate industrial environment. For example, if I am doing a pick and place application, I am not supposed to enter those region. So if I'm supposed to enter, definitely there will be a issue for me, either for me or to the robot. So robot need to be operated in a certain environment. So we used to have developed such a system that we have certain light curtain mechanism or lightning sensor or lidar sensor. Whenever I step into the region of robot, the robot automatically turns off and gives to and raise the alarm that in HMI screen you can see there's interruption in the operation. So the robot will automatically halt its working functionality. So these are the basic laws of industrial robotic, and this is our history too. Initially, and many people used to say that due to the introduction of these robot, we going to face unemployment in the near future. But technically, I can't really accept that in terms of industrial environment. So in industry, job opportunity will be to be multiplied by many times. Actually, for example, I can say that the very first industrial robot is being utilized for the automobile sector, basically meant for an pick and place application, for die casting application. Die casting is nothing but material to be melted to its melting point. For example, most of the die casting industry will be using aluminum. They'll melt aluminum at 1000 degree or around such degree Celsius, and they used to pour the molten metal for a die, not to make engine or some other parts. So it's been very harsh environment, a very tough environment for human to work. Even in Chennai, party based area, we have worked for some largest Tamil Nadu based industry group. So they have a schedule that before introducing a robot over there, they used to work like in the format. For example, they will be continuously working for 6 hours or 4 hours. After that, they used to given a break for 2 hours, and it's mandatory for them to have a 2 jar of buttermilk. So if he's not been able, if he's avoiding such sponsorship or such buttermilk, he is not taking that, his body used to face a huge problem. So uh, robot helps in working for the adverse condition where humans can't work in that position. So it's been designed in the way that it is not a replacement for a robot. It actually support a human to work in the safe environment. You might have even seen a lot of persons doing welding in the lit shop or some other workshops in the street. So they can't do welding for continuously for more than 10 years, 15 years, or 20 years. Even though they have some productive gadgets, it's not possible for them to maintain a proper eyesight. So even as a human, being a robot programmer too, we too face some problems. For example, if I am not having even if I am having some proper gadgets for coolers, sometimes my eyesight used to affected. I'll be taking a leave, or I'm even unable to open my eyes too. Even when I'm using a robot to teach a welding application, we used to face such problems. So it is very hazardous to the environment. So robo used to prevent and safeguard human from that adverse condition. And indirectly, if you study the government report of Industry 4.0 in Germany or some other advanced nations, they simply says that these robots used to create the opportunities for the engineers. For example, if they are deploying, for example, in Ford, we have given the robot, and we have given some other PLC plants too. There, where they are able to produce more than 400 cars per day. So that is possible only with the help of this technology. And if I am giving, for example, if you are selling a robot, that robot need to be operated by a person. So it needs an operator, and to be maintained in the proper manner, we need a certain maintenance engineer for them. And apart from that, there will be separate project engineers to, they'll be deciding on the future model. So they'll be selecting a model. So if they want to select a robot, they must be having some sufficient knowledge in the robot too. So indirectly, it used to create opportunity for the skilled labor rather than the unskilled labor. So unskilled labor used to be replaced, of course, and those jobs can be easily replaceable in the near futures too. So thus, the robot used to create a job opportunity for the skilled engineers, and we have a lot of expectations to in the market. For example, we are around 12,000 to 14,000 robots being commissioned in India. When comparing with advanced nations like Korea, Japan, Germany, and China, they have almost around 1 lakh industrial robots being commissioned. You can see the gap between those countries and our country's implementation. And the second model is called as famless. I will show with the picture, that will be very easy for you to understand. This is a very first model. Okay, is a very first model actually called as Unimate. Is being designed by George Dewalt, is the father of the industrial robot. How he developed the system, it's based on a polar technique. This is basically meant for die casting and work for the Ford manufacturing. And this is a cook of, this is the first electromechanical based robotic system. Initially, all the robots being designed in terms of mechanical, pure mechanical structure, and this is a first electromechanical in the 1960s and 1970s. But nowadays, entire robot system is being made from complete electrical uh, design, and it's been programmed by the programmers. And again, the silver arm, it used to this structure is being designed like a human hand, just to mimic the activity of human hand fingers to lift the job for pick and place applications, being developed by MIT staffs and students. And these are the robot parameter. I can explain with some other videos that you can better understand that. I've already asked the question that who can perform better, whether human or robot. I hope only person have mentioned that is human used to perform better. Let me show you a video, and after watching the video, you just comment on this sector. I hope you might have got some idea. Okay, can anyone explain it? What you have observed over there? Okay, simply we can say that they used to mimic the activities from the human, and they have programmed the robot to perform the operations of the human. But uh, when the scenario changes when it's been a long term operation. For example, they are supposed to make it for the 1,000 cuts. We humans used to get tired when we are performing certain operations, but robots don't have such tiredness. If we are programming it, the robot tends to work even for 24/7 if we are able to provide a proper maintenance to it and proper environment for that. For that, we need such ideal conditions. So this is a major reason that robot outperform the human. So we can't simply say the human is better than robot or robot is better than human. It's completely based upon the application and the requirement. For example, if this scenario has been taken for 10 jobs to cut, the human used to be dominant in this position. So robot is to make the progress, but human used to get tired. This is a major difference. The reason I showed this parameters that this video is that to explain these parameters. So degrees of freedom is nothing but how many access been provided. For example, if I'm using a six-axis robot, the robot's been flexible to operate in six different orientations. So it have 6 degrees of freedom, and it's need a definitely need a working envelope means the area where the robot can work. For example, if I'm using a 0.15 meter reach robot, so I can't ask the robot to perform a job for more than 2 meter range. So we need a certain range in the what in the specification the robot have to work for it. And next is kinematic. For example, if the robot has been designed in the way for different application. For I will show the pictures of different models of robot. For example, the painting robot is different, welding robot is different, cutting robot. Each differs based on its application, and the payload too plays a vital role. For example, if I want to lift a box, we have worked with some soap manufacturers and electronic appliances in the Chennai zone and Pondicherry zone. um, we will be lifting a box around soap box for about 180 kgs. So if I want to lift that box, I need to select a robot model according to that requirement. I can't use a 5 kg capability robot at 50 kg or 100 kg. So for that application, we have utilized MS220 category, which is capable of handling up to 220 kg. So our selections be based on this. So these are the basic parameters, and this follows the supporting notes for the robot selection. And this is our maximum specification. We have robot up to capable of handling up to 900 kg, and we have such reach too. So these are the basic anatomy how a robot's been uh, segregated. These are the basic technical. Without these, the robot can be processed out. At least you need a controller, manipulator, and drives and sensors. So control is actually what we technically call as the brain of the robot system, where it consists of drives and other programming controllers being fitted, and every communication device is being fitted in this CPU. And you can observe I can show you. You can see a mouse point. I think so. This is actually called as pitch pendant, through which we used to program. It acts as an interface between the human and the controller. So using that pendant, you might have watched in the video too. Using that only, we used to do programming and other functionality to jog the robot. So it plays a vital role. And these are the manipulators. Manipulator is just what you have watched in the video. The blue color structure actually called as manipulator. And these end effectors decide what kind of applications are supposed to be utilized. For example, if I'm using if this in this picture you can see a gripper which is meant for pick and place application. If I'm attaching a welding charge, you might have utilized some arc based welding in first year, I think so, in college. So if I'm able to attach that torch to the robot, that robot can be utilized for the welding application. So based upon the application, we'll be deciding the end effector. So this from this end effector we can decide which application we are supposed to use that robot. And drives, and most of the drives what we are using for the industrial robot is the electrical based drive, but you might have seen some hydraulic and pneumatic side drives which is being used in the early stage. Some strong players in the hydraulic and pneumatic systems, they still utilize these types of motor, but most of the industrial robots being utilized in terms of servo motors. I hope you might have studied the importance of servo motor in the syllabus too, where with the help of this encoder we can able to uh, get the exact position of the robot. That's why we prefer the servo motor. And these are six basic axes. So this is an example of articulate robot what you have seen in the video. and it has six axes of movement. For example, if first three axis called as SLU, which is a major axis movement, and next three is the minor axis movement. So S used to be defined as swing. L used to represent lower arm, upper arm, rotate, bend, and twist. So you might have seen that different manufacturers they have their own programming structure too. In Yaskawa, what is the language we use is Inform 3, and it's actually a combination of assembly language and C language, basics of C. So it's not very difficult for EC engineers to work on it. So we can easily program a robot. Suppose if I am able to give the robot to you and able to train you for 3 to 2 days, I can make the basic operation by I can make you to do a basic operation in robot too. So such a easy languages. What the main player is that I have to take care of all the mechanical activity, civil activity, and I have to do wiring. So it's not being engineer. I'm not. We used to think that suppose if I'm educating and if I'm graduating from the field, I'm supposed to do only a program. So we can't restrict ourselves to a particular department. This in terms of factory automation, we are supposed to work with multiple domains. Even I'm from ECE, but I have worked for the civil works. For example, if I'm mounting a robo, which is about 110 kg, there are some basic structures need to be followed, some methodology to be approached. So I used to think if you are a robotic engineer, you are supposed to take care of the entire commissioning of the robot. So we'll be planning the position with the help of EG based system. Might have studied EG in the first year, right? So from the diagram, we interrupt what is the sufficient place to place the robot, and what is the drill to be done, what is the maximum depth I need to do a pedestal for the robot, and even from fencing to the handover of the documentation, you are supposed to be taken care of that. So if you are to be entering this in department, you're not being restricted to some one particular tool. That's a mistake I have done in my college days. I'm expecting that you're not supposed to do such mistakes too. Try to get exposure in multiple field. I'll show this is actually structures, basic structures how the robot to be given. Or by seeing the technical presentation, you might be understanding that if you are going undergoing any technical presentation. This is just an overview. And apart from that, industrial robot, the new generation robot is called as cobot system. These industrial robots comes under the category of industry 3.0 basis system. But still, since ever since the 2014 and 13 introduction of industry 4.0 by German government, we are focusing on promoting and extend this technology to a next level platform. That is, some person have rightly mentioned that we are trying to utilize the other IT based sector support for the industrial robot to improve the productivity and increase efficiency. For example, with the help of this technology, even I can able to operate and control the entire robot from my place. It's not necessary for me to visit a plant. In Yaskawa, we have cockpit software, which is a software platform. For example, the company is been utilizing 300 to 400 robot. I can easily monitor what is the performance. I can monitor the shift performance, whether it's been going good or bad. Is in whether the graph is green or red. I can monitor from my phone. So it is not necessary for a plant manager to visit a plant. He rather than he can sit in home, or if he's visiting some other plant in some other country, he can monitor. Even he can control the system. That's a very specialty that we have given to our customers. So we utilize such concepts, and similar to that IoT based platform, and some other IoT 4.0 based robotic, we have cobotic system. Cobot is nothing but a collaborative robot which is capable of working alongside a human, which has been lacking in terms of industrial robotic. Cobot can work along with the human. For example, if suppose a person have entered a region of robotics operation, the robot suddenly stop, and once we left, it automatically regains the operation where it have left. And main feature of this system Copart is that it doesn't require a skilled person to do a programming. Just by doing my gesture, I can show the picture too. I can just mimic the activity. I can just move the arm, and I can pinpoint the point. So it is not necessary for me to write a program. The program will be automatically generated. So this is a very highly effective, and these are a racing field in terms of industrial robotics in the future. Actually, this is a HC10 model. Is an industrial robot which is being available in the right left side. The right you can we have basically two pics. Actually, one is a blue color robot is an industrial robot, and white and blue combination is a robotic system. And these are the application. Okay, there is a question. How can robot can distinguish one robot from a human being if both faces are covered? It doesn't perform by looking at the face actually. We have many platform. For example, if the robot will be mounted in the area, and that area will be that shop floor will be fitted with some mat. Any not only human, any obstacle that steps into that mat, that sensors trigger the command for the robot, and robot automatically stop. In terms of industrial robotic, if you are considering a robotic system that can able to touch it by when the while the movement of the robot when it's been obstacle it's been touched by in even a very little sensitive area, it's been commanded in the way that it will stop immediately. It's been designed in such a way. It's not only based on the pictures, based on the motions. You might have seen some CCTV camera that can even detect the motion. No, that's similar to that. We are using some other technologies too. But what is the major trouble? Since Copart is a development stage, we have not developed for that Copart system to be can be utilized only for pick and place application. So for that purpose, we can make it out. And this Copart finds application in high R&D and pick and place and a highly fragile environment, like for glass landing application. So if a human are holding and handling a glass about 6 feet tall, it will be very risk for him. It may be very thin. So there are a lot of probability of accident occurrence. So in that environment, they prefer cobalt. But this cobalt is still in development. We have not developed for the painting or building applications. So still we are working on that concepts too. These are the most common industrial application in Chennai and Coimbatore based region. Based in Tamil Nadu, we have lot of opportunity. For example, you can communicate with the mechanical persons too. They have some exposure with the CNC machine. For each machine, they will be employing a certain operator to do a performance. Once the machine have done the machining work, they used to align and keep the jobs. So instead of allocating a person for individual CNC, a single robot can we have developed a project that single robot can work along with the multiple CNC, even with the 5 or 4 CNC machine. So we can save a job and also we can save the time. So there's a lot of difference I can show with the pictures too. So handling is a major industry platform, uh, and handling has been subdivided into many platforms: palletizing and depalletizing, machine tending, making of stocks. For example, by I will be making, for example, if I'm working with the cement factory, that cement sack will be allocated in a neatly arranged manner in terms of rows and column. This arrangement is called as palletizing and depalletizing. If I'm making it in terms of rows and column arrangement, it is called as palletizing. If I'm de-assembling that part, is called as depalletization. This is one of the example of 15 axis robot, which I have mentioned in the earlier stage that this robot can work alongside a human, which is capable of working very efficient than the human in terms of lab research. You can even see some research papers in European countries. These robots been mainly implemented for atomic research and medical research, where humans are not supposed to expose such environment. These robots plays a vital role. Of course, it's been a bit costly when comparing with other robot. Since it's the first prototype of 15 axis in the entire market, it's very costly, and it used to mimic the human activities of an entire human being. It has 7 axes along the right hand side and 7 axes along the left hand side with the middle axis. Some models, some customers used to expect with the camera. So at the top, at the neck, we used to fix some camera which gives guidance for the robot too. Such system have been utilized. If you have visited some stalls in industrial exposure, we have even placed this robo for ice cream supply as an ice cream supplier and even as a coffee supplier. If you are visiting some stalls, you might have seen such robots too. So to demonstrate how versatile this robot to be, and this is a misintending application. The what you are seeing is a CNC machine. The robot used to load the job, and unloading can be done with this robot. you can observe that the structure has been different for different application. For example, this structure has been different, and you can observe for pick and place this structure has been different. So the robot physical manipulator has been designed in the way for achieving a high uh, efficiency, and this has been designed that made this have been made in the for achieving 100% accuracy. And for each application it size and and its position to be is different. So some packing and pick and place application robot need only 4 or 5 axes. It's not necessary for me to have 6 axes. So based upon the application, axis will be determined. For since to maintain the industrial robot category, it will be consist of minimum 3 axes. So these are the different model for pick and place application. And Chennai, we have lot of requirement of building application. For example, in Royal Enfield alone, we have around 400 Yaskawa robot. So you can imagine how what is the expectation, and even you can watch in the Discovery Channel some other programs. You can see a lot of industrial robots being deployed, not only for building, for gluing application, painting application, dispensing. We are using this robot. So basically, we'll be using with the MIG welding, gas welding mechanism. So these are the sample models for spot welding. We have worked with the Indian Railways in terms of spot welding. We have worked with some railway coaches in Chennai, and we've done a lot of projects. Personally, I involved around more than 10 plus welding based projects. So we have such a lot of requirements in Korean companies and Japanese companies in India. And assembly section. This is basically meant for huge line assembly factories like car manufacturers. uh, we'll be having a press machine. The sheet will be the car, actual mechanical part is being designed of the car. So for metal sheet bending and fixing, and for die casting application or assembling and and some other activity can be carried out using these models. I'll show the model. This is basically meant for assembly, but it being dedicatedly mostly used for medical and other R&D based purpose. So this is meant for dispensing. And what is the specialty is that this robot again can be utilized as a pick and place robot. I even can configure this robot for a welding application. That's the specialty is being made out. And this is a painting robot model. So you can observe this structure has been completely different. It's been designed. Even that the first video I shown to you, you can see this model of robot EPX series. So based upon the reach and height, that numbering will be different. You can see 1250 means it's actually in terms of mm. So it can reach 1.25 1.25 meter range. Its range actually 2900 means actually 3 meter robot. So according to recommend, we will be selecting these models. And you might have utilized some idea base, have some ideas about 3D printing. uh, so if I'm able to interface a laser gripper, if I am able to fit a screwdriver mechanism in the robot gripper, I can make it to the such application. So it has been highly versatile, and even I can do laser welding, even I can perform underwater welding too. So it's been developed in a way, whatever maybe the solution need to be achieved, we can make it out with the help of this 6 axis angular movement. So this is how they used to support us. Okay, and let me share the videos of some car we have worked on it, and we have some slide short range PPT and some other videos too. Let me show you that. This is sample application of MIG welding. We work for the one of the top most American based car manufacturer in Chennai, and this been actually a job of side door. The car you will be opening the door, no? So that model has been welded. I have already mentioned that we used to provide a certain envelope, means a working environment. So within this region, robot are not supposed to be disturbed. So whenever the operators been working, when the job is being completed, we have developed a program that whenever the job is completed, the screen used to be slided, so those jobs can be unloaded. Again, he'll be fitting the basic job to be welded. So we have some safety mechanism over here too. And actually, this is a job for you might have seen some game polo. While playing the polo game, you must have seen some car, no, some mini car base structure. For that, we have developed some chassis mechanism. And apart from that, I'll show some other video too. This is an example of 15-axis robot used to assemble tab. Okay, you might have had some basic idea regarding this Yaskawa based automation. So let us have some queries. If you have any queries, if you want to have any discussion, we can have it by now. Since we are running out of time. So if you have any queries, you can ping me out. Yes, you can unmute yourself and you can raise me a question. Suppose if you are not comfortable with your voice, you can just ping me in terms of chat, so I can able to interrupt it.
Hello. Hello.
Suppose if you are not able to make it in terms of chat,
No,
sorry.
sir. Ask them to
Yes,
put
you can.
only in the chat, sir.
Hello.
Okay, okay.
Mute them, mute them. Mute them, ask all the doubts in chat only.
Okay, so okay.
Bharati madam, you read the questions if anything is in chat box. That way he can give answer.
Participants, kindly post your questions in the chat box.
One question is there. Please read. Shankar P. Read the question. That way sir can answer.
Bharti?
Sir, one question from Shankar P.
Bharti?
Uh,
Okay, sir.
Ma'am?
how a robo can distinguish one robo from a human, be a human being, if both the faces are covered?
Okay, sir. I've already
This is
discussed.
a question
Any,
from Sankar P.
okay, sir. We have already discussed that. Anyhow, I'll repeat the answer, sir. Actually, we in this industrial robot doesn't work with the images. When we are commissioning the robot, we used to use the mission image processing only for inspecting a job. So what we generally used to use that we'll be using some safety sensors. Whenever there is a disturbance between the transmitter and receiver, that disturbance will be made in terms of logic, either zeros or one. That feedback will be given to the robot, and used based on that feedback. Suppose we'll be writing in terms of case. If we want to speak technically, we'll be writing a if case condition. Or if it's ladder, we'll be using NO/NC combination. So based on that, the robot used to halt the operation. For example, some jobs like for spot welding application of heavy truck industry, multiple robot used to work alongside the single job for a single job. So in that situation, robo has been designed in a way that they are not to be collided. For example, we used to write a program called as incube setting. What is mean by incube setting is that if suppose two robots, the distance between the two robots is about 100 mm or 50 mm, the robot automatically used to stop. So the robot won't travel behind that particular point. That facility has been available in terms of industrial robot.
Okay.
Oh, nice, sir. Thanks, thanks. So another one girl named Anusha. She's saying, I agree with you, sir, but robot's performance was, I don't know, whether the robot's performance was better than human. That is the question.
Actually, we can't say that. We have worked with the welding too. Personally, being from a programmer, I'll be asking guidance from the welder. For example, if we are doing a commissioning a robot for a welding robot, we'll be inspecting how these human used to do welding. For example, we used to get support from them. What is the welding angle I have to keep, and what is the uh, uh, percentage of amps and voltage that I'm supposed to use for the welding. So they are the basic platform, but of course we can't simply depend on the human. For example, in this COVID situation, most of the top companies are able to perform, so they are not dependent on the facility of the human. Let me consider an example. Suppose if we are being a person, we have some personal commitment. So if the production is being made out based on the 5 persons, they are the only professional welders. Actually they are not able to achieve come to the plant. What is the rate of the production per day? It be completely affected. For in order to satisfy that, robot can work once it's been programmed, it can work for a long time. There won't be difference, and it'll be performing terms of bulk production. For example, if I'm doing a welding for 10 jobs, I'll be definitely need a rest or some break to perform the same way, but robot doesn't. So in
Yes.
that application, based on application, we can say, but most of the industrial application, robot can outperform the human. That's my answer.
Okay. One question, sir. Is it possible to achieve Six Sigma or more with implementation of robotics?
Definitely we can. Of course, again, depends on the management. So we have worked with some industries. It's based upon their implementation based on their management and their working.
In India,
And
any
with the
company
help
is
of
there,
these
sir,
robot,
with the
we
Six
can.
Sigma implementing using robotics? Any company is achieving Six Sigma in
Actually,
India?
there are a lot of companies in India. They maybe not be visible to some other person. Some you may not may their know their names. You may not be aware of their names, but
Mhm.
they have such systems. Basically they are from some other countries. Even our India-based groups are doing that very well. Some companies are around the size of some department blocks alone, but they be performing a lot. They'll be making that Six Sigma too.
Participants, any questions? You can ask the questions because he's having good experience in robotics, industrial experience. He involved in many projects. So whatever the questions you have in mind, you can ask. No hesitation. All are concentrating in completing the feedback form.
But you can interact because it's not a normal college seminar, or
Yeah,
I'm
yeah.
not speaking technical towards your subject. Actually, it's been a rare
If
opportunity.
you want to speak to him, you can. If you want to ask question directly, you can unmute your audio, and you can ask. No problem.
So if they want to talk, they have to raise their hands so that we can able them to unmute themselves.
Yes, right. And feedback, excellent session, sir. Thank you from students. Okay, fine, sir. I think there's no further question. I think they got a clear idea based on your presentation itself. I think who is giving vote of thanks, madam? Yes.
Sir, I'm here. I'm Tamil Shelvi, sir.
Please give.
Yes.
Anyway, one time we confirm with the participants whether they are giving any questions or not.
Yeah.
Ma'am, somebody is raising his hand.
Yes, Prasanth, you can continue.
Yes.
Somebody is raising hand. Shall we proceed?
Proceed with vote of thanks.
You can proceed with vote of thanks.
Yeah, thank you. Good evening, everybody here. So I would like to thank the management and the principal for giving their support for organizing this webinar.
Hello. Hello. Hello.
Your failure.
Yes, we can hear
Hello.
you.
Sir, sorry, sir. Because of this network issue, I raised my hand with a delay.
Okay,
Sir,
okay. Please, sir. Please, sir.
Generally, for the computer science engineering students, so if they want to work in this
I would
area,
like to thank today's speaker, Mr. M. Sundar, AGIIT. I would like to for helping and
Commission.
hello.
Sir, just a minute, madam. One
Somebody
participant
is raising
asking
a
question.
question.
One participant raised a question. Please wait.
Okay, thank you, sir.
Sir,
Sir, here
sir.
for the students coming from the computer engineering background, if they want to enter into this robotics area, so they should be familiar with what type of languages in the present scenario, sir. Because in my curriculum of the CSC, so Java, C, embedded C will be there for those people. Some universities they may be having this Python or something.
Okay,
For
sir.
this, which languages are suitable exclusively for robotics, sir?
Actually, it differs from manufacturer to manufacturer, but most of the algorithm, most of the programming is completely based on the C languages and actually assembly language, what we are studying for microprocessor and microcontroller, right? So that we'll be using the combination of both assembly language and C in terms of Yaskawa, and most of the robot too the same. And some is completely based on the C and C++ compiler based on the manufacturer. But if you are strong with C and assembly language, be very easy to do any programming.
Okay.
And nowadays the programming structure has been very made very easy. That I've already explained the Cobalt system too. The manufacturer's been trying to make it out by using a flowchart mechanism. I can simply give a start command and in command and some blocks. Robot can perform. Just like pick and play mechanism, robots has been developed. It's been the programming complexity has been reduced day by day. So it won't be a concern for any department person.
Okay, sir. Thank you, sir. Thank you. Sir, you can unmute me and you can proceed, sir.
Tamchali ma'am?
yes, Bhargavi.
You can proceed, ma'am.
Good evening, all. I thank you all for the enthusiastic participation. I thank Mr. Sundar, Senior Application Engineer from AGIIT for giving such a very interactive and useful, informative session. Thank you, sir. I would like to thank Mr. Praveen from AGIAT for helping us in organizing this workshop. Thank you, Mr. Praveen. I would like to thank our head of the department, Dr. P. Sivam, for guiding us in organizing such workshops, webinars. I would like to thank the coordinators, Bhavani Shankari ma'am and Bharati ma'am also, my friends and colleagues. Finally, the participants, all the participants for their enthusiastic participation. Thank you one and all.
Thank you, sir.
Thank you, sir. Thank you.
Thank you, sir.
Thank you, sir.
Participants, kindly fill the feedback form posted in the chat box to receive your e-certificates.